This is AS Pure Maths Notes. We're in Unit 6, Circle Geometry, and we're looking then at example 4. Find the equation of a circle which passes through the points 1, 6, 3, 2 and 2, 3. There's two methods for doing this. So this is method 1, perpendicular bisector. Now, this is a wee bit laborious, but we'll see how we're going. So these 3 points are on the circle. Let's pretend this is point A, this is point B, and this is point C. We're going to effectively draw a couple of chords on here. So a chord, remember, cuts the circle like this. There's one of the chords there, and there's one of the chords there. And we're going to find the equations of the perpendicular bisectors of the chords. So how are they going to look? They're going to cut this exactly in half, and because it cuts it exactly in half and at right angles, they then go through the center of the circle. We're going to find the equation of this line here. We're going to find the equation of this line here. So it's cutting at right angles and it's cutting it halfway. And whenever we then solve those two simultaneously, that will give us a center. Once we have the center, we take one of our 3 points and find the distance. Once we know the center and find the radius, then we can find the equation of the circle. So perpendicular bisectors, that's what we have. So first of all, we need to start then with the line AB. So AB, we're going to find first of all then the midpoint. I'm just going to try and read off the midpoint of AB. Again, you can use your formula if you wish, but there's A and there's B. It's 1, 3, so halfway between 1 and 3 is 2, halfway between 6 and 2 is 4. So the midpoint of AB is the point 2, 4. I also want then the gradient of AB. It's going to be y2 minus y1, so it's 2 minus 6 all over 3 minus 1. 2 take away 6 is minus 4. 3 take away 2 is 3, so that's then minus 2. So here is my AB. I know this point here is 2, 4, and I know the gradient of this is 2. That means the midpoint, no, the gradient of the perpendicular bisector, so it's supposed to be a wee right angle, then must be a half. So I know the gradient of this line is a half, and I know it goes through the point 2, 4. So I can substitute that into y minus y1 equals mx minus x1. Y minus 4 equals a half x minus 2. Y minus 4 equals a half x minus 1. Y is a half x plus 3. So that's my equation of this line. I now need to do the same for BC, and once I've done that, then I solve those two simultaneously. So let's make sure we can see BC. There's plenty of space for this. Sorry for the rearranging here, and you get the idea of what we're doing. So here's BC. No, you can't see it. Here's BC. So I want then my midpoint of BC. Halfway between 3 and 2 is 2.5. Halfway between 2 and 3 is 2.5. So that's my midpoint. What about my gradient then of BC? Which is going to be y2 minus y1 all over x2 minus x1. 3 take away 2. 2 take away 3. 3 take away 2 is 1. 2 take away 3 is minus 1. That gives me minus 1. Therefore, of the perpendicular bisector of BC then must be 1. So I know the point and I know my gradient, so I can go ahead and substitute. You can substitute into y equals mx plus c. You know what, let's do this just for the variety of it to see that it still works. Y equals mx plus c, y equals 1x plus c, and then it's the point 2.5, 2.5. and that gives me then c equals 0. So it doesn't get much more simple than that equation. It's just then y equals x. So we now need to solve those simultaneously. So point, so you can see it, of intersection of two lines is the center. So y equals x, and my previous one, y equals a half x plus 3. So y equals x, and we have that, so I'm going x equals a half x plus 3. Take away half x from both sides, I get a half x is 3, and that gives me then x is 6. Substituting it in the y equals x, then y is 6. So my centre then is going to be 6. We have the centre, we now need to find the radius. So radius, then we're going to use our distance formula. So we have 6, 6, and let's pick one of our coordinates here. So it's going to be 1, 6. So it's going to be, let me see, 6 take away 1, all squared, plus 6 take away 6, all squared, which is, that gives us 0. Obviously 6 take away 1 is 5, 5 squared 25, and so my radius then in this situation is 5. So my equation of the circle then y, no, is x minus 6 all squared plus y minus 6 all squared equals 25. Rearranging that, if you wanted, we could get x squared minus 12x plus 36 plus y squared minus 12x plus 36 equals 25, and that gives me x squared plus y squared minus 12x, so that should be a 12y there, I'm sorry, minus 12x minus 12y. 36 plus 36 is 72, take away the 25, and it gives me 47. And that's us. Next video then we'll show our method 2. You can do it by simultaneous equations then as well.